In this video, I'm going to demonstrate how we can determine the class of an address in IPv4, whether it's a Class A address, Class B address, or a Class C address. And actually, we'll include Class D and E as well, even though those aren't used as commonly in subnetting. So, in order to understand this, we need to know how that binary system works. So, if you need to freshen up on your binary, take a look at some of the other videos and they may be able to help you here. So let's say we start with an address that is 183.94.122.73, just for an example. And we need to determine which class of address this would fall into. Well, in order to do that, let's see what the range is on these different figures here, these different address classes. All these address classes fall into a certain set of numbers. So in order to see this, we can see that Class A is kind of an interesting one. Class A, if we take all of the IP range, Class A is actually half of that space. Class A is every address in binary that starts with a 0. And all the other ones start with a 1. So Class A is anything that starts like this. Any address at all. Any address that starts like this falls into B, C, D, or E. So literally half of the address space is A. Now, the largest number we can come up with here, the smallest would be all zeros, right? So 0. And if we were to put ones in all of this space, this number in decimal is 127. We could do the conversion, but it's 127. So 0 to 127 in that first octet is an A address, a Class A address. So literally half of the address space is taken up into that. Now for a Class B address, you could understand that 128 is where it begins, but where does it end? Class B addresses start with a 10 and then anything. Class C, D, and E start with a 11 and then other stuff. So half of that address space, the 10s, are all Class B. And these would all be Class A. So C, D, and E are only a quarter of the total possible address space. So the smallest number we can come up with here is 128, 1 and all zeros. But if we had a number that's 10, 1, 1, 1, 1, 1, 1, that number is actually 191, which is the range of the Class B. And if you're paying attention, you might notice that 183 happens to fit between 128 and 191. So this is actually a Class B address. But let's keep going for a minute. 192 is where Class C starts. Class C is any address that starts with 110. And Class D is 1110, and Class E is 1111. So of this remaining address space, if we chop that in half, and we say 110 encompasses all of the Class C addresses in the world. And then 1110 is Class D, which is our multicast space, and 1111 is Class E, and that's that reserved space that was reserved for some future use, but we've never had that future use happen, so now we're suddenly out of space. If we take a look at these numbers, what we're going to see is 1110 is actually 224, and 1111 is 240. So you can logically come up with this. and 239 is where that one ends, and 255 would technically be where the Class E range ends. You'll never see any addresses use 240 to 255 in that first octet because we never ended up using that reserved space. All multicast addresses will be within this range here, this Class D address space. But the big ones are these three. These are the three that you'll usually need to keep an eye out for because those are the addresses that are most commonly used when we are looking up the classful address of an IP address.